Hello everyone, this is Amit Bhardwaj, Senior Chemistry Lecturer of Chemistry in Sri Chaitanya Gosala campus, right? So, today we are going to revise a very important topic from electrochemistry named Faraday's law, okay? Just for introduction, as we have done before, electrolysis, okay? So, electrolysis have two type of questions mainly. One based on the qualitative aspects. It means if we do electrolysis of something, so which substance will get deposited at cathode and which substance will get deposited at anode, right? And the other one is a quantitative aspect that will tell you, okay, this substance will deposit, but how much weight or how much moles, or you can say how much volume will be produced at anode or cathode. Okay, which substance will deposit, it will come under the qualitative aspect of electrolysis, and how much weight of that or volume or moles will be liberated of that substance, it is our quantitative aspect. And now Faraday's laws will help us to understand that quantitative aspect, means how much mole or weight will deposit, right? So basically there are two laws in Faraday's concept, Faraday first law and Faraday second law, right? So let us start with the first law of Faraday. So what is the first law of Faraday, right? In electrolysis, in our electrolytic cell, we pass current or we pass charge through our cell, and this charge is responsible for the reduction or oxidation at both electrodes. So for longer time, if you pass the electricity or current, I will say, that means you are passing more charge, okay? So if you are passing more charge from the cell, that means it will do oxidation and reduction for the longer time, and it will deposit more amount of substance at cathode and anode, right? So we can say in simple words, the weight or amount deposited at any of the electrode will be directly proportional to the charge passed through the cell, or especially I say through the electrolytic cell, right? So as it is saying, according to this law, amount of chemical reaction, or you can say mass of the substance deposited at electrode during electrolysis, is directly proportional to the charge passed, right? How you can write this? So if I say this is the weight W. W is the weight of substance which will deposit, and this weight will be proportional to the charge passed, directly proportional I will say, right? To equate this, we say W equals to ZQ. What is Z here? Z is our electrochemical equivalent, right? Or I can write this as W equals to ZIT. Fine, because we can write Q as I into T, current into time. Clear? Before starting the questions from here, first of all let us understand what is Z here. As I said, Z is the electrochemical equivalent. So Z is the equivalent weight of that substance divided by 96500. Clear? So what is Z here? Electrochemical equivalent, and its value is equals to equivalent weight of that substance divided by 96500, right? So we will need Z to solve these questions, and to get the value of Z, we will need equivalent weight of the substances which will get deposited. In most of our questions, you will see, in most of times, Ag will deposit. So for Ag, what is the equivalent weight? In most of the questions, it's 108 gram. If you go for copper, it's 63.5 divided by 2. So you can say almost 31.75 gram, you can say, right? If you are going for aluminium, if aluminium deposit, it's almost 9 gram. If O2 gas is going to be evolved, okay, so its equivalent weight 8 gram. If H2 gas is getting evolved, 1 gram, right? So there are some fixed things for which all the time they ask questions. Or I am saying here Cl2. So it is how much? 35.5 gram equivalent weight. So I will use these only in my questions, and always question come from these things only. And how these comes? What is the equivalent weight? Equivalent weight is the molar mass divided by n factor, right? If I'm saying, imagine at cathode Ag is getting deposited. So what is happening actually, if you see, so Ag plus will do reduction at cathode and become Ag. So you can say it is accepting one electron here, so its n factor is 1. So how I can get its equivalent weight? Its molar weight divided by its n factor, 108. Clear? Similarly, if you go for copper, copper 2 positive will take 2 electrons and become copper. So how we get the equivalent weight of copper here? Its molar weight, that is almost 63.5 divided by 2. So we can say almost 31.75 gram. So by this method, by using the molar mass by n factor, we can find the equivalent weight. And you will see these things will come again. Okay, so please, you can keep these minds, you can keep these things in mind directly, or if it comes something else, so you can find the equivalent weight using this concept, right? Now just to distinguish, sometime iron will come. So if I ask you, if imagine ferrous ion become iron and getting deposited at cathode, so what you will say? Ferrous ion will take electron and become iron here. Okay, so in this case I will take equivalent weight as mass of iron divided by 2. But if there is ferric ion, it's Fe plus 3. If it is getting deposited, so here you can see it is accepting 3 electrons, right? So in this case I will say E is what? M by 3. So depending on charge we are getting n factor, and depending on that we can find equivalent weight, and using the equivalent weight you can find the electrochemical equivalent, which help us to solve the questions of first law of Faraday. Okay, so let us see small simple questions to understand this concept in detail, right? So we can see here, first question, when 965 coulombs of electricity is passed through the solution of copper sulfate, the amount of copper deposited. Clear, right? So very easy. I am depositing what here? Copper. So simply beta Z into Q. What is Z here? Equivalent weight of copper divided by 96500. And from here you can say how much charge? 96500. Clear? And what is the equivalent of copper here? You can see the given the molar mass. So it is 36.6 divided by 2. It is the equivalent of copper divided by 96500, and it is the charge. So from here you can solve very easily, right? I think you'll get how much? 3.18 grams. Okay, so easily we can solve our question and you can get the answer. Fine, right? If you go for the next question, what it is saying? How much chlorine will be liberated on passing 1 ampere current for 30 minutes? Okay, so first of all 1 ampere current. Okay, so what they are saying here, I how much? 1 ampere. How much time they are giving to us? 30 minutes. So be careful, convert it into how much beta? Seconds. So how much? 1800 seconds, right? So again apply the formula only. Weight of chlorine deposited will be the equivalent weight of chlorine here divided by 96500. What this thing is giving to us? Z, electrochemical equivalent, and IT. So I is 1 ampere only, and how much time? It's 1800 seconds, because Q is equals to what? IT, right? I is given, T is given. So if you solve it simply, you'll get an answer. Okay, if you solve this thing, first tell me again, just now I told you what is the equivalent weight of chlorine. It is 35.5, right? If you are taking Cl2, then 71 by 2, or just Cl if you are saying, so 35.5 divided by 1, right? if you see the reaction also, you see 2 of Cl negative ions will give us Cl2 plus 2 electron, right? So for Cl2, if I say, n factor is 2, that's why its equivalent weight is how much? 35.5. So put the value here, 35.5 divided by 96500 into how much, beta? 1800, right? Now just calculations, and if you solve, you will get 0.66 gram of Cl2 gas will evolve at n node, right? If it is getting oxidized, like Cl minus is becoming Cl2 and losing electron, so Cl2 will deposit at where? At n node, right? In the previous question, copper plus 2 was going at cathode because it was accepting electron and was doing reduction, fine? So next question, you will see the quantity of electricity needed to liberate 0.5 gram equivalent of an element, right? Very, very important point. Let us understand first of all. Look carefully. First law is telling us W equals to Z cube, okay? And W equals to equivalent weight of substance divided by 96500, fine, into Q. Now, if you see carefully, if I am passing one Faraday charge, through the ion or through the electrolytic cell, you see 1 Faraday charge is how much charge? 1 Faraday means 96500 coulomb. So this will cut down this. So 1 Faraday charge always deposit weight equal to the equivalent weight of substance, or you can say it will deposit 1 gram equivalent of substance. I am saying once again, 1 Faraday charge will deposit weight equal to the equivalent weight of substance, and if we go according to the number of gram equivalents, so 1 Faraday charge will deposit 1 gram equivalent of substance, right? Now what they are saying, understand carefully, they are saying they are depositing how much? 0.5 gram equivalent of an element. 0.5 gram equivalent of element means, if I know 1 gram equivalent of any substance will need how much? 1 Faraday charge, right? So 0.5 gram equivalent of substance will require how much? 0.5 Faraday charge, right? 0.5 Faraday option is given to us, yes or no? No, not given. So we will convert this into what? Coulombs. So I will say 0.5 and Faraday means 96500 coulomb, right? From here you can find beta. Easily you can see you will get half of this, na? So 482500 coulomb approximately, fine? So be clear, 1 Faraday charge deposit 1 gram equivalent of substance, or I can say weight equal to the equivalent weight of substance, right? Okay. So if you look for next substance, find the charge in coulombs required to convert 0.2 mole of this vanadium oxide. So you see here it's VO32 negative and converting into VO43 negative, right? In this transition, how many moles of electron are transferred? If you check beta, vanadium here is how much? If you find its oxidation state, it's +4, right? Whereas in this case, if you see, vanadium is present in how much? +5. So definitely, when you take its 1 mole and convert into its 1 mole, so it will require 1 mole electron, right? 1 mole electrons means how much charge? 1 Faraday charge. 1 mole electrons means 1 Faraday charge. Clear? 1 Faraday charge. But here they are saying they are just converting how many moles only? 0.2 mole. So 1 mole need 1 Faraday charge. So 0.2 mole will need how much charge? 0.2 Faraday charge. right? 0.2 Faraday charge, if I say in coulombs, they are asking in coulombs beta, so 0.2 into 96500 coulomb. Okay, if you multiply this, you will see you will get approximately 1.93 10 to the power 4 coulombs. It is in coulombs. If you go in Faraday, then it is just 0.2 Faraday of charge. Remember, Faraday is the bigger unit of your charge. 96500 coulombs will make how much Faraday? 1 Faraday, right? So easily you can answer. Now, next today if we see, when electric current is passed through the SD5 water, okay, 112 ml of hydrogen gas at STP is collected. So time is given, they're asking current, okay, right? So first of all, let us understand 112 ml of hydrogen gas at NTP or STP, you can say. Can we get the moles from here? Given volume divided by 22.4 will give us what? Moles. Or it is in ml, so I will take what here? 22400, you can say here ml. This is the number of moles from here. Okay, if we solve this thing, it is coming almost for what? 1, 2, that's 1 by 200. This is coming. Okay, these are the moles I am saying of which gas? H2 gas, right? So now I want to find the weight of H2 gas actually evolved. So I will say it's 1 by 200 moles. Weight of 1 mole H2 how much? 2 gram here. So I can say how much beta? 1 by 100. So we can say from here 10 to the power minus 2 moles. 10 to the power minus 2 grams of H2 gas is evolved here. Now we come to the formula easily. The weight of H2 gas evolved is equals to what? Z. Equivalent weight of H2 is 1, here 96500, and into IT. What is I here? If we look for I, we have to find, right? And time we have to, like they have given us 965 second only, right? 965 second. If you cut it down from here, what is coming? It's coming 1 by 100. Okay, and here you see weight of S2 also coming how much? 1 by 100. So weight also coming 1 by 100. Here it is coming 1 by 100 and is I. So from here if you solve, so I is coming how much? 1 ampere only, right? That's it. Clear? So just one formula, W equals to ZQ, or Q is what? I into T. Okay, good. Now we are coming to second law of Faraday. Okay, so second type of questions will come from second law. What is it? If we understand this diagram, these cells are connected in series with each other, and the current if you are passing, so same current will be passed through all these cells. Okay, same current is going to pass from all these cells if these are connected in series, right? And as we know, 1 Faraday charge always deposit 1 gram equivalent of substance. We know it very well, right? So depending on the equivalent weight of substance, you can say how much weight of substance will deposit. It depends. If I am passing 1 Faraday charge through two things, so it will deposit 1 gram equivalent of A as well as 1 gram equivalent of B. So if you want to find the ratio of their weights, if you want to find the ratio of the weights, how much it is deposited, it will depend on their equivalent weights, right? Clear? So from there you can say, what this law say beta? This law is saying clearly the weight of substance produced at electrodes will be directly proportional to their equivalent weights, right? Clear? So what is the main thing we have to understand here? If I am depositing A in one cell and I am depositing B in other cell, or maybe in two different electrodes, you can say, the ratio of this will be same as the ratio of the equivalent weights of A and B. This is the second law. If I am passing same charge through two different cells, so the weight deposited of A and weight deposited of B. I'm saying once again, I'm passing same charge. Same charge is depositing this weight and same charge is depositing this weight. So their ratio is what? Equivalent weights of both the things. Okay, clear? This law we have to use. This formula basically we have to use, right? Imagine I'm passing same charge from all these three cells. In this case, copper will deposit at cathode. Imagine here silver, here nickel. Okay, that qualitative analysis we did, and I'm telling here copper, here silver, here nickel. So I can say directly from here that the weight of copper deposited divided by weight of silver deposited will be equals to the equivalent weight of copper and equivalent weight of what? You can say silver. Or I can say similarly, weight of copper deposited divided by weight of nickel deposited will be equals to the equivalent weight of copper equivalent of copper divided by equivalent weight of nickel. Okay, and you can apply for this silver and nickel also, same thing. Clear? So this way we have to solve our questions. Okay. One more thing I will tell you, how to solve a question in little less time. Okay. So understand. Understand this point carefully. If I am passing, imagine in this one electrode I am depositing A plus converting to A. So I am depositing A by the same charge, and in the other I am depositing B plus 2 to B. So here we are depositing B in other cell, you can say, and here I am depositing C plus 3 and C. So in three different vessels I am depositing A, B, C, but I am passing same charge through all of these cells, right? So directly how we can go? All type of questions we can find from here. If you want to find the ratio, we are finding ratio. Which ratio, beta? First I am saying number of gram equivalents ratio, right? You want to find number of gram equivalent ratio, right? So it is always, if I am passing same charge through A, B, C, so if I am saying here it is A, here it is B, here it is C, and here number of gram equivalents, right? So you will see always it is what? 1, 1, 1. If imagine I am passing 5 Faraday charge through all of these, so everything's 5 gram equivalent will deposit. So here 5 will come, 5 will come, 5 will come, and finally ratio is what? 1, 1, 1. Clear? Got the point? If I want to find number of moles ratio, right? I want to find number of moles ratio. So we have a little shortcut for this. Do one thing. Take the LCM of charges like A plus B plus 2, C plus 3. Take the LCM of charges. Take LCM of charges and divide by the corresponding charge of that ion. Like if I want to find molar ratio of ABC, if I am passing same charge through three different cells, same charge, right? So here you can see what is LCM? LCM of A plus 2 plus 3, 6. So 6 divided by what is charge of A? 1. Here we will have 6 divided by B is how much? Charge 2. And what is it here? See, LCM 6 divided by 3. So what is coming from here? So I can say directly 6 ratio 3 ratio 2. Okay. Take the LCM of charges and divide by the corresponding charge. Okay. You can get easily your molar ratio. Okay. Second type of question. And third type question, if they want to ask the weight ratio, they are asking weight ratio. How much weight ratio? Now you have the molar weight. Okay. So you have the molar ratio. Easily we can get it better. 6 into molar mass of what? A here, 3 into molar mass of B here, and 2 into molar mass of what? You can say here C. Okay, so this will give you the weight ratio. So they will ask these three type of question only from second law of Faraday. I am saying once again, very important. Number of gram equivalent deposited will be always 1, 1, 1 if I am passing same charge. molar ratio will be LCM of the charges of all of these divided by the charge of corresponding ion, right? And weight ratio, if you have the molar ratio, then easily you can get the weight ratio by multiplying their what? Molar masses. Clear? If we have moles, we can easily convert into what? The weight. Alright, clear? So this is it. Now let's try some questions. Okay, fine. Let us see what they are saying here. On passing current, two cells connected in series, okay? Connected in series means I am passing same charge. Containing solution of AgNO3, Ag will deposit here, and which one? Copper. 0.18 gram of Ag is deposited. So amount of copper deposited they are asking. Very easy question again. So I will say weight of copper deposit we have to find. Weight of silver given to us is equal to what? Equivalent weight of copper divided by equivalent weight of silver, right? Weight of copper we have to find how much weight of silver is deposited, bache? It is 0.18, fine, equals to what is the equivalent weight of copper? I told already, but if you don't know, then copper plus 2 takes 2 electron become copper. So N factor 2, 63.5 is the molar weight divided by 2. So 31.75 you can say. 31.75 is the equivalent weight of copper divided by 108. 108 is the, you can say, equivalent weight of silver, right? So from here easily we can find the weight of copper. So from here you see 31.75 divided by 108 and into what? 0.18, fine. So you can get from here easily your answer, fine. Okay, now next thing we will see, next question. Two electrolytic cells, one containing acidified ferrous chloride. Be careful, ferrous means they are saying here Fe plus 2, and another acidified ferric chloride. Be careful, what is the meaning of ferric, beta? Ferric means Fe plus 3. So don't put the equivalent weight blindly. First check sometime, they can change the charge of ions. So the N factor will change and the equivalent weight also change. Okay, so be careful about it. Fe plus 2 here, Fe plus 3. They are asking ratio of iron deposited at cathode and you can say in the two cells. They are saying ratio of iron deposited. Fine. Now we know the charge. One thing is Fe plus 2 and one thing is Fe plus 3. Right? And imagine by passing same charge, I want to find the molar ratio of both the ions which will go and deposit at electrodes. What is charge of this? Plus 2. What is charge of this? 3. Clear? What is LCM? 6. LCM is 6 beta. LCM 6, and what is the charge of this ion? 2. Right? LCM 6. What is charge of this ion? 3. Right? So in this case, you see what is coming from here. It is coming 3, it is coming 2. Clear? So 3 ratio 2. Molar ratio, they are not writing here, they are asking weight ratio or molar ratio, but fine, molar ratio same na. If I want to find weight ratio, then 3 into what here? 56. And here also 2 into 56. So that's why weight ratio also comes same in this case, because molar mass of iron is same, because both electrodes are depositing iron only, right? So what is the answer? 3 ratio 2. Fine, easy. Now next one is, an electrolytic cell contains a solution of Ag2SO4 and has platinum electrode. Fine, a current is passed and they are saying 1.6 gram of O2 is liberated at anode. So at one electron Ag will deposit and other electrode O2 will deposit, right? So they are asking the amount of silver deposited. Fine, again easy one. Weight of silver deposited divided by weight of O2 deposited will be equals to the equivalent weight of silver deposited and divided by equivalent weight of O2 deposited, right? So what is the weight of Ag beta? We had to find, okay, how much weight of O2 evolved? 1.6 gram. Done. What is the equivalent weight of silver? 108. Clear? And what is the equivalent weight of oxygen? It's 8. Right? So if you solve it from here, this will give it you 0.2 and 0.2 will multiply here. So weight of Ag deposited will be how much? 108 into 0.2, right? It's giving 216 something, so 21.6 gram. You can easily get. Again, simple question, right? Okay, now next one. Okay, so carefully. A current is passed through two cells connected in series, and here at cathode they will deposit what? X, and in second cell they will deposit what? Y. The relative atomic mass is given, so they are asking this time the liberated mass. They want to ask the ratio of the liberated mass of X to Y. Clear? So let us see. What is that? I want to find weight of X deposited divided by weight of Y deposited. So this ratio is, we know very well, it is what? Equivalent weight of X divided by equivalent weight of Y. Clear? And now in this case, we don't know the masses to find equivalent weight. So I will say mass of what? Molar mass of X divided by its n factor. What is n factor of X in this case? You see carefully, X plus 3 is taking 3 electrons to become X. So n factor here is 3. Divided by equivalent weight of Y is molar mass of Y divided by, what is n factor of Y here? Y plus 2, right? So Y plus 2 is taking 2 electrons to become Y. So its n factor is 2. So it is 2 here, right? So if you solve this thing, what is coming from here? Can I write this way? It's coming mx divided by my. It is going upside 2, and here how much? 3. Okay? So this is our ratio of X and ratio of Y, which will get deposited. But again, they are putting something else. They are giving the ratio of mass of X and Y also, right? So what is beta mass of X and Y ratio? They are saying the molar mass or atomic mass of X and Y are in ratio 1:2. Means mx by my is 1/2, right? And further we have how much? It's 1/2 here. And what we are having beta here? It's a 2/3 here. 2 will cut down. How much coming? 1/3. Okay. So they will deposit in 1/3 ratio, right? So this is it beta. So this is our second law, and we have done almost five questions and almost all type of possible questions from Faraday's first law and second law. I hope this video will benefit you, right? Okay beta, bye. Thank you. See you later.